This is activity 3, which is a card sort. It says matching dilations on a coordinate grid. So you're going to be given 6 images, and there are 5 descriptions. One of the images does not have a description, so you're supposed to provide your own description of that image. And so it starts out with a trapezoid, and says this trapezoid is using a center of dilation of -1, -2. So -1, -2. So it's this point right here, and a scale factor of 3/2. So it's going to be multiplied. Each of these lengths on the original trapezoid gets multiplied by 3/2. So for example, if this length is this whole length is 1, 2, 3, 4 units. 1/2 of that is 2 units. 2/2 are 4 units, and then another half, so 3/2 times 4 is 6 units. So A is going to go to A prime. So remember, you start at the center of dilation and you draw lines out through each vertex to the corresponding point, which is going to be 3/2 times the original length. So scale factor equals 3/2. Each length is increased by 1/2 a unit. Now, the first one wasn't too bad. You can just, because it just moves along this horizontal axis. But these points that are on a diagonal or a slant are a little bit harder to deal with, a little bit harder to count and count out 3/2, or multiply even by 3/2. So you can use the vertical length and the horizontal length to get to each point. So this vertical length to get to the shorter side right here. All right, this vertical length to get to the shorter side is 3 units. 1, 2, 3, and then you're going to take that, multiply those 3 units by 3/2 to get to 4.5 units. So it's going to move this length out another 1/2 of a unit in length. So it goes from 3 units to 4.5 units. And then in this case, this way, the horizontal way, goes from 4 units to 6 units, and we saw that just a moment ago. So each one of every 2 units is 1/2, 2, 4 is 2/2, and 6 is 3/2. In this case, every 1.5 units actually is 1/2. So this is 1.5 units, another 1.5, and 1 unit, so 1.5 units, and then another 1.5 units is that 3/2. So each length gets increased by 1/2 of the original length. A little bit hard. And so to go to place this point, this is this length is 1, 2, 3 units long. So this length is going to be 4.5 units long. So you're going to increase it by another 1/2 of this length, which is 1.5 units. And so this is going to end up being 4.5 units from this point across here to this point. So this is 1.5, another 1/2 and 1, or another 1.5 is 3, and another 1.5 is 4.5 units. So it gets you to right there, and you can check that it falls on a straight line that goes to this vertex, falls on a straight line that goes to this vertex, and falls on a straight line that goes to this vertex. So I use these vertical lengths and horizontal lengths because it's hard to see, what is 3/2 of this length right here? Well, 1/2 is this diagonal plus 1/2 of this diagonal. Well, maybe you can do it that way. 2/2 gets you to here, so it's 3 of those diagonals, and then 3/2 is another 1 diagonal and 1/2. Well, that's not too bad. This one is harder for me to see. You can, where's 1/2 and then the whole length, and another 1/2 of that gets you to here. It's just harder to see. All right, the next trapezoid, the next image is another trapezoid, but instead of getting scaled up by 3/2, this one gets scaled down by 1/2. Make it a little bit tricky. that the center of dilation is at point -3, 4. So you go over -3 and then up 4, and the center of dilation is right there. So each of these lengths, if you draw a line from that center of dilation to each of these lengths on the trapezoid, the original trapezoid, they're going to get reduced by half that length. So this length from here to here is going to get reduced by 1/2. So it's going to take that length to right here. So this is 1/2, 2/2. So this length gets reduced by 1/2. This length is the same. It's the same as this length. So this length is 1/2, 2/2. So this length gets reduced by 1/2. And this length along this line right here, this is 1/2, 2/2. So this length gets reduced by this to this 1/2. All right, it's hard to see, hard to do. So again, I went to using vertical and horizontal lines. And it looks like this. I'm going to zoom in on this in just a second. But I labeled the second trapezoid A prime, B prime, C prime, D prime. And this one's hard to deal with because this longer side of the scaled trapezoid, which is reduced by 1/2, lays right on top of the shorter side of the original trapezoid. So it gets very confusing to see what's going on. But let's zoom in on this. All right, so if I start with the center of dilation, and this point way out here, point A, is 2 units along a horizontal axis and 6 units along a vertical axis. So each of those lengths gets cut in half, gets multiplied by 1/2. Well, 1/2 of 2 is 1. So this point, the corresponding point, is going to be 1 unit out from the center of dilation and 3 units. Half of 6 is 3. So it's going to put that point right there. Notice it's on a straight line from the center of dilation through this vertex out to the original point. This is the same on the other side. This is 2 units out. So the scaled half is going to be 1/2, half of that, or 1 unit. And this is 3 units this way because this is 6 units along the vertical axis or the y-axis. All right, these 2 points that are the shorter side, the original length is right here. I just actually showed you that. This is because they overlap. This is 1 unit and 3 units. This is the original length. You can't see it because it's overlapped by the scaled copy, but this is 1 unit out and 3 units in the vertical direction. So half of 1 is 1/2. And half of 3 is 1.5. So it takes you to right there. So this point and this point are in the corresponding positions. So this is half a unit out and 1.5 units along the vertical length. So this trapezoid, now notice that all these 2 points fall in a straight line through the vertex and this point here, and these 2 points fall in a straight line through each vertex to this point out here, and all of the lengths are parallel. So this red trapezoid is a scaled copy of the black trapezoid using a scale factor of 1/2. Okay, the third and fourth images are both circles. In one case, this circle is going to get, this circle right here is going to get scaled up using a scale factor of 2. And in the second case, the circle is going to get scaled down using a scale factor of 1/2. So the first one, so dilate the circle using center 0, 0 and a scale factor of 2. Well, this is the original circle right here, the radius of 2. So the length from the center of dilation to each of these points, actually every single point on the circle, is 2 units. And if that gets doubled, so each point on this circle then is double the first circle. So each point on this circle now has a radius or has a length of 4 units, which is the radius of the scaled circle. So the radius of the smaller circle is doubled, scale factor of 2, from 2 units to 4 units. So each one of these lengths gets doubled from 2 units to 4 units all the way around. So they all become radiuses of the circle, but instead of being 2 units long, they become 4 units long. So each of these units is twice as long. This is the same length as this length, so therefore the total length is twice as long as the original length. All right, and the second circle says dilate the circle using center of dilation of 0, 0 and a scale factor of 1/2. So the radius of the larger circle is halved. So scale factor of 1/2 from 2 units to 1 unit. So it starts out at 2 units and it's scaled down by a half of the 2 units, which is 1 unit. So it starts out at 2 units, and then it's going to get scaled down to the smaller circle by multiplying 2 times 1/2, or 1/2 of 2 is 1. So they're going to end up shrinking this circle down to a radius of 1. So every point on the circle is 1 unit away from the center, which is also the center of dilation. All right, 2 circles. This is the 5th image, and this triangle is the one that has no description that goes with it. So you have to write your own description of how this triangle gets scaled. So this smaller triangle here is dilate the triangle using a center 0, 0. So the center of dilation is 0, 0, and a scale factor of 2. So we're going to go from this smaller triangle that has the black vertical side right here to the larger red triangle using a scale factor of 2. And because the center of dilation is 0, 0, so this center of dilation is 0, 0, so this triangle rests on the y-axis at 0, 0, and also this vertical length, this horizontal length rests on the horizontal axis. So that means that each of these coordinates can just be multiplied to get the corresponding coordinate that is 2 units, scale factor of 2. That's twice as far away from 0, 0. So the coordinates can be multiplied by 2, which is the scale factor. So in the first case, this point right here is at point 2.5, 0. So 2.5, 0. So if I multiply the x coordinate by 2, that's going to take me out to 5, and 2 times 0 is 0. So this length is going to be doubled from 2.5 to 5, and it's still along the x-axis because the y-coordinate is 0. So here it is zoomed in a little bit. So this is 2.5, 0, and 2 times that. 2 times 2.5 is 5, and 2 times 0 is 0. So it takes you out to this point right here, which is 5, 0. And along the slant here, along the line, or the longer side, that's the original point is at 2.5, 1.5. Each one of these units are 2 of the lines. It's a little bit confusing for a moment to look at. You have to realize that this is 1.5 units, although you're counting 3 lines up. So this has a x value of 2.5 and a y value of 1.5. Well, 2 times 2.5, we already did that one, that's out to 5. But now 2 times 1.5 is 3. So this length is going to go from 1.5 to 3. So you're going to go out to 5, and then 2 times this 1.5 is going to move the coordinate up to 3. So it's now 5, 3. And here it is zoomed in just a tiny bit. So this 2.5, 1.5 gets dilated out along this line. Remember, you start at the center of dilation, and all the dilations are on a straight line from that center of dilation through each vertex. So this is going to go out to this point here. So this point has twice the length, by the way. And so you might be able to see that a little bit hard. But if I count it out, 1, 2 and a half, or just count these lines, 1, 2, 3, 4, 5, 1, 2, 3, and then count these lines. This go out to 10 and up 6. 1, 2, 3, 4, 5, 6. If you just count the lines. So this length here is the same as this length here. So the total length is 2 times. So it takes you out to the coordinates 5, 3. So the red triangle is 2, each length is 2 times the length of this smaller triangle. So a scale factor of 2 and a center of dilation of 0, 0. This sixth figure is pretty tough. So they give you a center of dilation of -4, -3. So -4, -3. So it's going to be right there. They want you to use that center of dilation to dilate this triangle 3 halves with a scale factor of 3 halves. So what that means is, so here's the center of dilation, -4, -3. So each length is going to be increased. It's going to be the unit length from the center of dilation to each of these vertices, but then that length is going to get increased by another half unit. So it's 3 halves times that length. So I'm going to show you one way to do this, and then I'm going to show you another way to do this. So 3 halves is the same, by the way, as 1 5/10, or 1 1/2. Okay, so the first point is from the center of dilation to this vertex. Then another point is from the center of dilation to this vertex. And the last one, the center of dilation to this vertex. So each of these lengths is going to be 1 times plus another 1/2 times. So it's 3 halves times each of these lengths. So start with this one. And so we're going to take the whole length, and then we're going to figure out what 1/2 of it is. It's right there. And so now the final length is 3 of these halves. So this is 1/2, 2 halves, and the third half is going to take you right there. This makes it also kind of tough to look at and to see what's going on because it maps right over this point, which is a second point on the triangle. So it goes right there. All right, so just keep that in mind for a moment. This is this point right here mapped 3 halves of its length to right here. So now I'm going to change color because now I'm going to work with this point that's at this coordinate. So this is 2, 3 coordinate, x value of 2 and a y coordinate of 3. So I'm changing color so to let you know it's different from this mapped point. A little bit confusing. All right, so what's 1/2 of this length from the center of dilation? It's right here. So you can tell because it's 1, 2, 3, 4, 5, 6, and half that length is 3 of these diagonals. So it goes right to here. And so now the length is just increased by that 1/2. It's 3 halves times each of these lengths. So this is 1/2, 2 halves, and the third half is right here. So it's 3 more of these diagonals. So now we have 2 of the points on the triangle, this point and this point. Well, the third point's easy to place. It's right there because this is a similar figure, just dilated, scaled up as this triangle. So this point has to be right here. It's a right angle, so it has to go right there. How do you get there? It's 3 halves times this length. Well, this is 1/2. The whole length is 2 halves. And the third half, now this one's a little bit tough also. So another way of seeing this is to count 3 units over, 1, 2, 3, and 2 units up. So that's 1/2. 3 units over, 2 units up. That's 2 halves. 3 units over, 2 units up. That's 3 halves. So now we have this triangle that's scaled up 3 halves, a scale factor of 3 halves of each of the lengths of this triangle. Now that's kind of tough. I can't draw all the arrows because it just gets too busy, too messed up. All right, a second way to look at this is to realize that not only do these lengths get scaled up by 3 halves, but every single length associated with this triangle, whether it's vertical lengths this way, horizontal lengths this way, every other length, every single length gets increased by 3 halves, or is multiplied by 3 halves, using a factor of 3 halves. So I use the vertical length and the horizontal length to help place this same triangle by multiplying the vertical lengths and the horizontal lengths with a scale factor of 3/2. So each length is increased by 1/2. So it's 1.5 times, or the scale factor. So every 4, so if this is 4 units, well, 3/2 of 4 is 6. So let me zoom in on that for a little bit. So if this is 4 units, 3/2 of 4 is 6. 3/2 times 4 is 6. This is 1/2 times 4 are 2 units. 2/2 times 4 are 4 units. And another half of 4, which is 2 of these units, gets you to 6. So this point right here is going to be slid up to here along this horizontal line, and then it's going to be moved over 4. It's 4 units, and 3/2 of 4 is again 6 units. So it's going to be moved over from this point over to here 6 units. So originally it went up 4 units and over 4 units, and in the scaled copy it's going to go up vertically 6 units from the center of dilation, 6 units, and along the horizontal axis 6 units. So it's going to get you to right there, and that's that point that maps right over a point that already exists in this triangle. Makes it kind of tough. The next one is this point, which is going to map to here. Well, if you go up 4 units, 3/2 of 4 is 6. We already did that. So it's 1/2, 2/2, 3/2. Now what's 3/2 of 6? Well, 1/2 of 6 is 3. So it's 1, 2, 3. 2/2 of 6 is the 6, which is right there. And 3/2 of 6 is 9. So it's 3, 6, 9. So 3/2 times 6 is equal to 9. So this goes up 4 units and over 6 units. So the scaled copy goes up 6 units and over 9 units. And the last one, this is at 9 units, 9 units. It starts out at 6 units, 6 units. And maybe by now you can see that 3/2 of 6 is 9 and 3/2 of 6 is 9. So it's going to go from 6 units to 9 units. So again, this is 1/2, 2/2, 3/2. So you should write that on a piece of paper and multiply 3/2 times 6 and see how you get 9. So 3/2 times 6 is equal to 9, and 3/2 times this 6 is equal to this 9. So this is the scaled copy, or dilated or scaled copy of this triangle right here. Each length is 3/2 the length of this original. So this is 3/2 the original. So this is 1/2, 2/2. This is 1/2, 2/2, 3/2. So this is 1/2, 2/2. So this is 1/2, 2/2, 3/2. And this length is 1/2, 2/2. So this is 1/2, 2/2, 3/2. So each of these lengths are 3/2 of each of these lengths, which means increasing each length by 1/2 of the length. Kind of tough.